So this is your lesson 3.5 over proving lines parallel. We're going to recognize angle pairs that occur with parallel lines, and then we're going to prove that two lines are parallel. So go ahead and fill out the warm-up questions, push pause, and then play and check when you're ready. So a slope parallel should be the same slope, so 1/3. Slope perpendicular should be opposite reciprocal, so flipped and then the sign changed. And then we're putting it into point slope form, with this being my x1, this being my y1. We end up with a double negative here, distributing the 3/4, and then adding 2 to get your final equation. So proving lines parallel, remember the magic happens only if the lines are parallel. So you can use the angle measures to prove that those lines are parallel. So it's kind of going the other direction, which is called the converse. So when we use the lines parallel already and prove those angle relationships, then we are using the angle measures. And then if we are going the other way, then we're using the converse of those angle relationships. Okay, so what proves parallel? Converse. What proves parallel? Converse. So say that to yourself 3 times. What proves parallel? Converse. So down here, we're going to look to see if we can determine if those lines are parallel. So these are, looks like alternate interior, and they are congruent. So that means yes, by the converse, because what proves parallel? Converse of alternate interior angles theorem. And then this one, we kind of look at this relationship here, and those don't really have a relationship. This being 111 and this being 70, their sum is over 180. So that does not help us prove that those are parallel. Here, these are same side, and if we add them up, 58 and 122, that adds up to 180. So if those same side interior angles are supplementary, by the converse, what proves parallel? Converse of same side interior angles, then we can prove those lines parallel. All right, these right here, corresponding, they're the same, they're both x, and so they are congruent. So then the converse, what proves parallel? Converse of corresponding angles. Postulate helps prove that those are parallel. All right, so down here, can we prove parallel if 1 is congruent to 2? Alternate interior being congruent? Yes, by the converse of alternate interior angles. All right, over here it's giving us that 3 and 4. Oh, it's saying these are parallel. And then if 3 is 80 and 4 is 100, those add up to 180. So can we prove, so I guess actually we're trying to prove if 4 is 100. So since these lines are parallel and 3 is 80 and these are same side interior, they should add up to 180. So angles 3 and angles 4 are congruent. We'll put congruent in there by same side interior. So we already know those lines are parallel. That's when this magic happens. And that same side interior angles theorem helps us prove that those are, sorry, not congruent, that they're supplementary. And so the measure of angle 3 plus the measure of angle 4 has to equal 180. And if we know 3 is 80, then we can plug that in and we can subtract and get that the measure of angle 4 equals 100. So putting in some reasons here, this would be definition of supplementary, this would be substitution, and this would be subtraction, which we don't have to turn it into a proof, just making sure that we kind of cover all of our bases there, and you can see all my steps. All right, so now we're going to give the information that would help determine which lines, if any, are parallel. So if they tell us that 3 and 7 are congruent, these are alternate interior between A and B. So it would prove that A is parallel to B by the converse of alternate interior. All right, our next pair of angles here, they're giving us our 9 and 11. And I can see that those are corresponding and they go along with A and B. So A parallel to B by the converse is again what proves parallel? Converse of corresponding. 2 and 16. So these go alongside L and M this time. And they are alternate exterior. And if alternate exterior are congruent, by the converse, we can prove those lines L and M parallel by the converse of alternate exterior. 5 and 12 being supplementary. 5 and 12 adding up to 180. So those are same side interior going alongside L and M. So L parallel to M by the converse of same side interior angles. All right, 12 and 14 being congruent. Nope, those are just vertical. Do vertical angles, the converse of vertical? No, there is no converse of vertical. So this doesn't prove parallel. All right, A and B, we know that these are parallel. Tells us right here. So 2 and 7, we're not going to use the converse because we already know that that's parallel. So what kind of angles are these? That's the conclusion. Alternate interior is what helps us conclude that those 2 and 7 are congruent. All right, A and B, we know they're parallel. So what kind of 4 and 7? Same side being supplementary, so same side interior angles theorem. And then 4 and 5, with that same picture, already still knowing that A and B are parallel, so 4 and 5 alternate interior. And we don't need the converse again because we already know that they are parallel. So taking a look at this picture, we know that they are parallel, that's given. Corresponding angles are congruent, so 3 and 7 are congruent, and then 6 and 7 are congruent because those are vertical. So these both have 7, so we can take this and put it together with either transitive or substitution. All right, down here, given. And if we were trying to prove the lines parallel down here, we would just need to make sure that we had converse. Remember, what proves parallel? Converse. But we already know that it's parallel because it's given. Corresponding angles are congruent. So it looks like I'm going to try and get 1 and 8. So I'm going to have angle 1 and I'm going to have angle 8. And I have a feeling they're going to be congruent to the same one. So vertical angles 8 and 5. And so this would have to be congruent to 5 as well. And yep, 1 and 5 are corresponding. So they are congruent. And if they are both congruent to 5, they are congruent by the transitive property of congruence. All right, this is given. And then the linear pair postulate is the LPP. Write that out so you know what that is. So if it's a linear pair, then it's 180. And then corresponding angles are congruent. So it looks like we are going to be kind of looking for something to replace the 1 with. So measure of angle 1, looking to replace it probably with a measure of angle 5, because that's kind of what's changing from here, step 2 to step 4 there. So let's look and see if 1 and 5, yep, those are corresponding angles. So those are going to be congruent or equal, and we can replace that, and that is substitution when we replace. So you can try any of these, pause and try this one, and then push play and check when you're ready. All right, so these are corresponding, so that's why they are equal. Had a little typo there on number 3. It should be 125, not 12. So 125 plus 15 gives me 140. We're just simplifying. Then we're going to subtract the 140 to get our x equals 40 on that one. So you don't really need to get these down like word for word, step by step in the proof. But basically, perpendicular transversal theorem, this is what you mainly need. And all of these kind of is just that first piece. So if you have the lines perpendicular to the same line, then those lines will be parallel if they're perpendicular to the same line. Perpendicular lines, they form right angles. And then right angle congruence theorem just says that all right angles are congruent. Because they're all 90, they're all congruent to each other. So those are the main pieces to kind of remember about those. You don't have to get down all of those step-by-steps kind of in those little mini proofs.